Hello everyone. So let us discuss the first three problems from the Leetcode weekly contest 273. So let's start. The first problem is a number after a double reversal. So reversing an integer means to reverse all its digit. As you can see that reversing 2021 gives you 1202. So reversing 123000 like double zero actually give you 3 to 1. So the leading zeros will not be retained. Fine. Now you're given an integer nums, reverse nums to get a reversal 1, and then again reversed 1 to get reverse 2. That is the original string. Just return true that if reverse 2 is equal to nums again, which means that if you take the number, reverse it, and again reverse it to bring back to the original number, it should be same. What is the case in which it will not be same? So let's say that if you take some number that is having some zeros, okay, that is 12300. If you first reverse it, all the leading zeros will be deleted out, and then when you again reverse it, it will only be having 123, not the final zeros at the end. Okay, so if I just draw it out, so if there's some number that is, let's say like this, if you reverse it, it will become 00321, but these zeros are not included, so it will only be like this, 321. And when you again reverse it, it will become 123. That is, this string and this string are not equal. Even if you like reverse it and then again reverse it, these two strings are not equal. Why? Because the zeros that are in the end will be removed out when you goes from this to this part, and thus these are not same. But if you take, let's say, 231, if you reverse it, it will become 132, and if you again reverse it, it will become 231. So these two both are same. So what is the main difference? If any number has some zeros in the end, then that number cannot be reversed back to its original form if you do this double reversal, or else the number can be reversed back. So you just have to check that whether it has some zeros. Instead of checking all the zeros, just check that there is only one zero at the end. If at least only one zero is also there, if there are, let's say, 1000 zeros or 1 0, it doesn't matter, that number will be get shortened out. So just check that whether the last digit is 0 or not. If it is 0, then it will not become to the same number, or else it will become to the same number. That's the whole logic. So we just check the last digit. Also, there is one thing that is given you actually in the examples only, that if the nums is 0, if you reverse it, anything happens, then it will only remain to 0. So that's some sort of an edge case. So if the nums is 0, then the answer is true only. But if it is not 0, you will just check that whether the last digit is 0 or not. If it is 0, then the answer is that you cannot reverse it to the original number, or else you can return it out. So that's the whole condition. You just check out whether the last digit is equal to 0. Okay, if it is, yeah, the answer is, like, you cannot convert it, as the answer is yes. That's the whole return statement. Fine. Let us move on to the next problem. The next problem is not too difficult. It just states that you are given a robot and a grid, actually, as you can see. Now what the problem statement states that you are starting from this particular position that is given to you as the start position, start index, and then you're given some like instructions that you have to go right, down, left, right, and so on. So these are instructions. You just have to tell that, okay, at which point the robot can move. The robot cannot go out of bounds. So the robot will start doing these instructions at any point of time. If the robot go out of bound, it will stop, or else the instruction get ended out, which means that, let's say, there are 10 instructions and it has followed all the instructions, so it cannot do any more instruction, it will stop. So there are two cases at which the robot can stop. Either it will go out of bound, all the instructions go over. So you just have to tell that starting from the ith point. What I mean by this is, so let's say that this is the string. Now if the robot start taking the input from the first point itself, then the robot will do all of these operations as right, down, left, and up. If the robot start taking operation from the second index, that is this, so it will be right, down, left, right, left, up. If the robot start taking from the third index, then it will be down, left, up. If the robot start taking from this index, that is the fourth index, and then down, left, up. So if the robot start taking from every index possible, what is the maximum number of moves the robot can do? That's the whole problem. Now, because the constraints are very small, as you can see, 500. Okay, the 500 only, and the length can only be 500. So these are very small. You can do this in a very brute force way. So that's the most brute force way. Just take every robot, start from every index, and just start iterating that if the robot will do a right move, okay, then you have to just take from the current index, go to one move right, whether it is inbound or not. If it is inbound, then do increment your steps and keep doing that. So you will only stop, either the robot will go out of bound, or else your number of moves will get stopped. That's the whole problem. I cannot draw it out. Like, it is very simple. I hope you get the point. So these are the 4 directions, and these are the direction letters for which they correspond. Okay, this is a is valid function, which means that it's just check that whether it is going out of bound or not. Okay, then what I've done is that this is the ith point, because I have to start from every point possible. Okay, then for every point we'll take out our starting index, and then this is the total number of steps it will do. I will start from all the ith index, and what we'll do here is that I will check that what is the what you can say, what is the direction I want to go. I want to go left or right, up. If I want to go, let's say, left, I want to append those particular direction coordinates into the coordinate I am on. I will just check that whether I have gone out of bound or not. If I have gone out of bound, I will break out a point that I will not move any further. If not, I will increment my step and keep going any further. At the point after I've completed the whole job, I will push back how many steps I have done for starting for that particular point of time. And that's the whole answer. Nothing more to complicate. Cool. So that's the whole solution for the second problem. Let us move down to the third problem. The third problem is, yeah, that is a good problem. Stay focused. You will understand a lot of new things in this problem. What you can see here is that the problem statement goes like this, that you are given a 0 indexed array of n integers. That is, the name of this array is ARR. Now the interval between any 2 elements in ARR is defined as the absolute difference between their indexes. So the interval between any 2 same numbers is the absolute difference between the indexes. I will tell you more, but stay with me. More formally, the interval between ARRI and ARRJ is their difference between the indexes. Fine. Return an array intervals of length n, where interval of I is the sum of the intervals between ARRI and each element ARR with the same value as ARRI. It just means that I will tell you with the same example. You will take the same example. Let us take the same example and it will become more clear. Let us remove this out. The 2 1 3 1. So 2 1 3 1. Then what you can say, 2 1 3 1 2 3 3 2 3 3. Now what you are actually trying to say here is that you have to build an answer vector or an array, whatever you can say. Okay, now what you can see here is that in this, if you take any index, let's say if you take the first element, you have to find out all the elements that are having the value same as 2. That is, this element is also there. Now taking this element as you can say, like the center element, find out or add all the distance between this element and the element that is having the same value as this element, add the absolute difference between the indexes. So this is the same element. So this is the absolute difference between the indexes, which is just the distance between these 2 elements. That is equal to 1 2 3 4. So 4. Okay, now let's take the second element. For this element, the element that is having the same value is this. Fine. Now taking this element as starting, like the center element, find out the difference or like the addition between all the elements that is having same value as 1. So this is the difference between them. Difference, I mean that what is the index difference, or you can say that what is the distance between these 2 indexes or these 2 elements. So this is just the 2 difference. Now stay focused for this 3. If you take for 3, what you can see is taking 3 as a center point, see how many 3s are there in this array. So there are this 3 and this 3. Now what you can do is just add all the 3s, like all the distance between them. So this is one distance, that is equal to 1 2 3. So 3 plus this is one more distance, 1 2 3. So this is 1 2, the distance 1 2 3, and this 1 2 3 4. Actually this is 4. Turns out to be 7 only. Yes, 7. I hope you get the point. So what you're actually seeing here is that for every digit, what you can see here is that for every digit or every number, see what all numbers are same to this digit, like same to this, as you can say, number, and just see that whatever numbers are same to this number, what is the absolute difference between those indexes, and add all of them out. And that's the whole problem. Now what you can see here is that the constraints are pretty large actually, so you cannot do this in O of like in a more brute force way. You cannot do this in O of n square, like for every number check what is all the numbers that are same to it and add all the differences. So that cannot be done because it is pretty large. You cannot do this in O of n square. How can you do that? So the first thing is you have to somehow know all the indexes of all the numbers that are same to it. So what you can do is that, okay, I can create a map of vectors. Okay, what I mean by this is a map of vectors. So let's move some part of it out so that it will become more clear to you. Okay, let us make a map. Okay, map is just used to store what all are the indexes that are having the same value for which I want to find out the absolute differences. So let's say that for 1, I am making a map that is mapped to all the indexes that are having 1 as a number. So the indexes are 0, 1, 2, 3, 4, 5, 6. Because I just want to find out the absolute difference between those indexes only. Na? So 1 is there at index 1 as well as 3. Okay, 2 is there at index, as you can see, 0 as well as 4. 3 is at index 2 as well as 5 and 6. Fine. Now what you actually have to do here is that you have to make an array. 2, 3, 4. And then what you can see here is that for the first index, I want to just find out the difference between these two. That is equal to the different 3 minus 2, that is equal to 2. Oh, we get the point. So this is actually 2 only, I think so. Yeah, 2. Then for this element, as you can see, the absolute difference between these 3 and 1 is equal to 2 only. So I will store it at the third index. So 0, 1, 2, 5, 6. So then it equal to 2 also. Fine. Then for this index, so 0th index, the difference between these two actually is equal to what you can say 4. The 4th index also equal to 4. For now 3, for the second index, it is equal to difference between these two numbers. So the addition of the differences between these two and these two, because I have stored the index actually separately. So that is why I can use those index only to find out the absolute difference between them. So what you can see here is that what I'm doing actually here is that if you take some, so let's take this example only. Let's take, there are 5 numbers. Let's say there are 5 3s and the indexes are, let's say x1, x2, x3, x4, x5. Let's take an example. So for finding out for finding out the value for this index, what I actually have to do here is that I will add the difference between this, and this. Okay, just add the absolute difference between this value, this value, this value, and this value. Fine. Now I want to then get to the value for this. If I just remove it out, then it will become more clear to you. Let's remove this part. I hope you get the point what we are doing here. So if you just again draw one more thing, x1, x2, x3, x4, x5, then it is like this. Okay, so now when I want to find out the value for this, I will be finding out the absolute difference between these two indexes, this. Then for the next case, again, if there are 5, I will be like taking like this, 1, 2, this, and this. Okay, so I hope you are getting visualized how we are doing this. So for every ith number in this whole array that we have deduced for the same numbers, because we have to find out these for the same numbers, because I have stored only the indexes of the same numbers. Fine. So can I transfer from this state to this state an O of 1? That is the whole problem. If I have this thing, I can find out for the first number absolute difference from the first number to all the numbers in O of, let's say, n. Because n is not actually n, it's actually the size of the numbers that are having the same values. But let's say that if there are n in worst case, all the numbers are same. So there are n numbers and I have appended and find it out all the n numbers. So for the first number, I can directly in O of n find it out. No worries. That is, take the first number and find out the absolute difference from this to this, absolute difference from this to this, and this to this. So that will take O of n. That is fine. But if I again do this for this number also, from this to this, so it will again take O of n. So again O of n. So it will be O of n square then. Hope you get the point. So I don't want O of n square. Can I find out in O of n only? Like for the first case, I find out in O of n. Then again, I will find out for all of them in only one O of n. I just again iterate from left to right. So can I convert from this state to this state in O of 1 only? If I have this state answer, can I convert from this state to this state in just O of 1? Can I directly convert it out? What you can directly observe here is just, if I just remove out the drawings again, it will become more clear to you, because I've messed up in so much. Let us draw it out more clearly. 5, 1, 2, 5. So the first state is this. The next state is this. what you can observe here is that in this state, this difference, this absolute difference is added in this. If you find out actually this absolute difference or this absolute difference is actually the addition between this absolute difference and this absolute difference. Absolute difference means the distance. Actually, absolute difference is actually the distance between these two. If this is 2 and this is 3, this is actually 1, which means that the difference between these two indexes is 1. And this is 5. So the absolute difference between these two is equal to, as you can see, 5 minus 2, that is 3. Or else you can add both of them, that is 2 plus 1 actually equal to 3 only. So this is just the differences or distance only. Okay, so if I just move this out. So what you can observe here is that this difference is in this also, in this segment also, this segment also, this segment also. So if the n segments, n minus I, because so as you can see, if I can say n segments, if the n, so not sorry, n minus 1, because the n this like n number, so n minus 1 segments are there, as you can see, like, so what all n minus 1, if I delete out this part, so it actually means that all of them are shifted by one position, as you can see, like, then it will be like this, because this part is deleted from all the segments. If all of them segments are deleted this part, then it means that all the segments are now starting from this point. So n minus time I will be deleting out this part, because how many points are there that are taking to the right. So it will become like this, but this is not added actually. This part is not added. That is going from to the left part. So how many are, like, as you can see, let's say that you can see some sort of fountain. How many fountains are going to the left side actually? So I fountains are going to the left, and I, like, n minus I going to the right. So it will just take that, I will, like, this amount is like this difference, n minus time I will delete out from the total values, and I time I will add to the total value. I hope you get the point. It is not too much complicated if you draw it out, because this part I am removing from all of these halves, but appending for this half, for this fountain, as you can see. So that is what we are doing. Then again, if you want to shift one more time to the left side, how many fountains are there? Now n minus 2 fountains are left. So for n minus 2, again this difference will be deleted out. So, and for, if I'm shifting to this point, how many fountains are there? So if I go to this point, there will be 2 fountains. So I fountains are there, so because they are shifted for ith position, so 2 fountains are there, and for all of them this distance will be added. Okay, this amount of value is added, and that's what we're gonna do. And then we go, like, it is like just shifting. So how many fountains going to right and how many fountains going to left, just shifting about that. That is the whole logic for that. So let us go down to the code part. What you can see here is that this is a long value, because finding out how many total values are there. This is a map to store out a int to vector. So because how many, for a single number, how many indexes are there that are same, pushing all of the numbers into this map. That is, so let's say that I found out 5. So 5, at whatever index it is, I will push that. Then I will iterate over this map. So map has first the particular value I am on, and the second is the indexes. So I'm just concerned about the indexes. So for the indexes, what you can do here is, then there are some left fountains and right fountains. Okay, so left and right. Initially I don't have any left, so I have all the right ones. So how to calculate for the right ones? I will, for add the ith fountain, so for I have to calculate for the first state. The first state was that if there are, starting from the first value, all of the fountains are going to right. So I will be finding out, or actually adding, the absolute difference for the ith. So if this is the 0th fountain minus the value for all the ith fountain. So ith fountain minus the 0th fountain will actually give you the, or I'm just actually adding the absolute difference between the starting value and all the other values for the right fountains. So as you can see, right fountain is just adding out the absolute difference within the ith fountain and the 0th fountain, that is the starting fountain. Then I will iterate again from the second value. Actually, this is not first, it actually starts from the second value. So, or actually start from the 0th value only, because you have to also store the answer. So 0th value is how many fountains are on the left side as well as the right side. So initially there is no left side, so it is 0, and right side we have added on. So left plus right will give you total fountains that are for the particular index I am on, and it will store that into this answer vector. Okay. Then then what I'm doing here is that if it is not the last fountain, because the last fountain do not have any right fountains, if there's some left fountains also, what you can see here is that you have to first find out the difference, because you are going to the next fountain actually. So this next fountain is there, then how many left values are there? So, and there are right values. So left values, how many indexes are added, because it is 0th indexing, 0 plus 1, because if there are 1 fountain added, 2 fountain added. So this amount of fountain are added to the left side, and this number of fountains plus difference is added. So there are how many fountains that are added to the left side, into that difference is added to all of those fountains. And on the right side, that same difference is multiplied, but how many fountains I have to remove that difference. This total size minus, because I'm going to the right side, so I minus 1. Okay, these are the fountains that are removing from the right side, and this is the same number of fountains added to the right side. And this is actually just like adding this out and deleting this out. Left and right is just adding, and then again when we move to the next fountain, left plus right is the number of left going fountains and right going fountains. We will just add all them, and that's the answer. You will find out all the codes in the description of this video, so don't get any problem. You can like go over those codes again if you have any doubts. So thank you for watching this video till this end. If you still have doubts, you can mention down. Thank you for watching this video. I will see you next one. Till I keep coding, and bye.